Hi, if we go back to your objectives of learning objectives for week one, you'll remember, I hope, that there was a review on pH. What is pH? And I've thought a lot about this because most of you don't know what pH is, because you're not taught what pH is, not very well, usually in high school or anyplace else. They talk about the pH scale, they show you pictures, such as the one in your book, and the pH goes from 0 to 14. And they show color codes and certain things that are more acid than others, like lemonade or lemon juice is pretty acid. Then they can show you sulfuric acid, and they can also use litmus paper to show you how the differences in acidity change the color of the pH paper. And we can do the same thing by boiling red cabbage and using the juice from red cabbage to make our own litmus type test. Well, pH is a measure of acidity and or alkalinity. If it's alkalinity, we usually call it pOH, and if it's acidity, we usually call it pH. So what are some examples? Well, hydrochloric acid is very acid. Sodium hydroxide is very basic. What is sodium hydroxide? It's bleach. That's what it is. It's bleach. And in fact, if you look on the side of the container of bleach, it'll tell you this is a certain percent solution of sodium hydroxide, NaOH. And I think it's sort of funny because it's a cheap chemical that you can go to the store, and today you can go to places like Menards or Home Depot and find big stacks of outdoor bleach. So you can put sodium hydroxide in a bottle and sell it for $1 or $2 for a gallon. Or you can put a label on it that says outdoor bleach and sell it for $6 a gallon. And it's all the same thing. We're just a capitalist preying upon the ignorance of general society. So let's really talk about what pH is. And I've got some Wikipedia things here to look at, so here we go. What is pH? Oh, the pH scale measures how acidic or basic a substance is and ranges from 0 to 14. Okay, that's the EPA. Here's another one, Academic Brooklyn, New York University, basically, University of New York. So what is pH? pH is a measure of the hydrogen ion concentration of a solution. Solutions with a high concentration of hydrogen ions have a low pH. So if your number is small, you're more acid. And solutions with a low concentration of hydrogen ions have a high pH. So there's more OH. See, it's actually hydrogen ions and hydroxyl ions. So HOH is water. When HOH becomes dissociated, when water becomes dissociated into ions, and it does, any glass of water that is neutral has an equal number of equal number of hydrogen and an equal to the number of hydroxyl or OH ions. And that means a pH of 7. Okay, let's contrast a pH of 7 and a pH of 2 to see what the difference is. Okay, I've typed this out. We're going to compare pH of 7 with a pH of 2. Now 7 is bigger than 2, but 2 is more acid. How does that work? Okay, so pH is the negative logarithm of the hydrogen ion concentration on a base 10 scale, base 10 log. In this case it's negative, which means it's below 0. Okay, so let's take a look at a pH of 2. What is a pH of 2? It is a certain concentration of hydrogen ions, and by the way, pH, you can think of it as the power of hydrogen. Okay, think of it as the power of hydrogen. I'm going to move over here. So pH of 2, it's a certain concentration of hydrogen ions in a liter of water or liquid, and it's expressed as moles per liter. A pH of 2 is not 2 moles per liter. Remember that the pH is the negative log of the hydrogen ion concentration. So what does that mean? Well, negative log 2 is 0.01. It's 2 decimal places less than 0. And it's 0.01 or 1/100th mole of hydrogen ions per liter. And what's a mole of hydrogen ions? It's a gram of hydrogen ions. It's 6.23 times 10, no, I'm sorry, 6.22 times 10 to the minus 22 times 0.01 atoms of hydrogen. It's Avogadro's number times 0.01. Because the number of atoms or molecules in the mole of any particular compound or element is Avogadro's number of those atoms or ions or molecules per liter. Okay? So pH of 2 is more acid than pH of 7 because pH of 7 is 0.1 mole, of hydrogen ions per liter. Okay? Just ran out of space. Anyway, that's what it is. So you can see that this times Avogadro's number is a much smaller number than 0.01 times Avogadro's number. And this is why pH is so confusing. The negative logarithm, log base 10, of the hydrogen ion concentration. So the smaller the pH number in terms of its absolute value, the larger the number of hydrogen ions per liter. And of course, water, normally if it's pure water, is at pH 7 because water is dissolved in water. Remember we talked about salt, table salt being dissolved in water? Okay. When water dissolves in water, there's an equal number of hydrogen ions and hydroxyl ions. So we have a situation here that's somewhat unique, and somebody that was a chemist fixed up a situation, perhaps, to demonstrate acidity using red cabbage. And I'll get the demonstration up in just a minute and add to this because I have some red cabbage, and we'll take a look at it. In fact, I've made some videos, so I'll pull one of those up and just show you what we're talking about. Okay, so here's the lab and the red cabbage juice.
That changes pretty fast. So
Added some acid to that.
hydrogen ions.
That pink one, we added
Vinegar is also acid.
lemon juice.
Give me the vinegar. So, quickie. Now, baking powder. Let's add some of that to here since that didn't work. That should be tasty. Not much happened. Maybe that's because there's a buffer in there. Let's see what happens here. I didn't know what would happen with baking powder. I said, well, we'll just experiment. Not much. What about baking soda? So if we were looking
Okay, you can see the differences in color, and I'll stop it there, but I'll put a link on
this.
this. The other thing that you want to look at is remember that the opposite of pH is pOH, is hydroxyl ion concentration. So if there's an equal number of H and OH, we have a neutral solution, pH of 7. Very low concentration of free hydrogen ions. Why? Because the hydrogen ions have hydroxyl ions to combine with to make H2O. But if we overwhelm the solution with a source of hydrogen ions, then we can have a real acid created. Or if we find something like sodium hydroxide that'll put a lot of hydroxyl ions in solution where there aren't enough hydrogen ions to combine with, we'll get a very basic solution. It'll be slippery. In both cases, at high acidity or high alkalinity, your skin can be damaged, you can be burned, it can actually be poison, and so forth. Okay? So, what does this mean for your health? The enzymes in your body that promote and control the rates of chemical reactions in your cells require a very narrow pH to operate in. The pH has to be between 7.35 and 7.45. That's a very narrow range. Outside of those ranges, the proteins change shape, that are enzymatic, and they don't work anymore. And you really get sick and may very well die. Okay, now you'll notice on this screen down here, you can look up Mr. Anderson. He's got a nice video on acids, bases, and pH. Okay, Bozeman video. Just look up Mr. Anderson, acid, bases, and pH if you want to learn more. It's a very good one. He's also got a lot of nice videos on a lot of the topics that we're going to talk about. And so I hope this helps you understand pH. It's the power of hydrogen, and it's an expression of the concentration of hydrogen ions in a liquid solution.